All right. So, ladies and gentlemen, just to review, refresh your memory, when you're looking at a set of parametric equations, x equals f of t and y equals g of t, then remember we talk about the slope as a derivative of y with respect to x, and remember the derivative for parametric equations is dy dt over your dx dt. Again, we talked about where your dx dt cannot be equal to 0. The derivative, as we know, dy dx, is also going to be interpreted as the slope of your tangent line. And again, we're talking about the rate of change with y with respect to c. Again, another review about talking about the second derivative when we're looking at our parametric equations. Remember, we're taking the derivative of the derivative. But then remember, we have to divide this by your dx dt. So don't forget when you do that second derivative of parametric equations, when you take the derivative of the first derivative, you have to divide it by the dx dt. So when we talk about x prime of t, when we're talking about vectors, we know we have an x component, we have a y component. When we talk about dx dt, it is the rate at which your x coordinate is changing with respect to t, or the velocity of the particle in the horizontal direction. So that's going to measure your horizontal direction. Y prime of t, or your dy dt, is the rate at which your y coordinate is changing with respect to t, or the velocity of the particle in the vertical direction. So let's just talk about now the rectilinear motion when it comes to vectors. So first of all, your position vector, that is just your x of t and your y of t. Your velocity vector can be expressed as the first derivative of the horizontal and vertical component of the vector. So that is going to be your x prime of t and then your y prime of t. So we talk about the slope of your tangent line with vectors. That is going to be your y prime of t divided by your x prime of t, or your dy dt divided by your dx dt. Your acceleration vector will just be the second derivative of the horizontal component and the second derivative of the vertical component. So now you have to read carefully. We talk about the speed of the particle, or when we talk about length, we talk about the magnitude of your velocity vector. So again, they may ask you about speed or magnitude of your velocity vector. It's going to be this formula, the square root of dx dt squared plus your dy dt squared. So we talked about the arc length of parametric functions last class. It's that part in the integral. It's that square root of your dx dt squared plus your dy dt squared. Arc length, just remember when you're traveling from a time is equal to a to b, or we can also talk about distance traveled. So again, we talk about the length of the arc, or arc length, or distance traveled. You're going to be using the integral from a to b of the square root of dx dt squared plus your dy dt squared dt. So these are just some vector formulas that we're going to take a look at. All right. So like I said, it kind of it relates really well with parametrics, but like I said, they don't have this topic in your textbook. All right, just relating to vectors. All right, let's take a look at some examples now. So we've got a particle in the xy plane. The position is given by x of t is equal to t to the third plus 4t squared. Y of t is equal to t to the fourth minus t to the third. So the first thing they want us to do is to find dy dx as a function of t. So remember, dy dx is going to be equal to taking dy dt and dividing it by your dx dt. So what is dy dt then? Well, what's the derivative of t to the fourth minus t to the third? That's going to be what? 4t to the third minus 3t squared over. Now take your dx dt. The derivative of t to the third I know is a 3t squared plus derivative of 4t squared is an 8t. So I can simplify this because I can factor out, remember if it's free response question you can leave it alone, but again if it's multiple choice you can factor a t squared out of the numerator. That'll give you a 4t minus 3 over factoring a t out in the denominator. That'll give you a 3t t times 3t plus 8. And then you can cancel your t, and that's going to give you t times 4t minus 3 over 3t plus 8. Again, so like I said, if it's free response, you don't have to worry about simplifying it. But again, if it's multiple choice, make sure you simplify it. So now find the velocity vector when t is equal to 1. So remember, velocity is the first derivative. So I'm going to take and find my x prime of 1 and find the y prime of 1. So then x prime of 1 is going to be equal to taking 1 and plugging it into that first derivative. So again, I found that first derivative to be 3t squared plus 8t. So that's 3 times 1 squared plus 8 times 1. So that's going to give me 11. So the horizontal component of my velocity vector will be 11. So then to find my vertical component of the vector, I'm going to find y prime of 1. So I found my dy dt to be 4t to the third minus 3t squared, so I'm just going to plug in a 1 for t. And that's going to give me a 1. So then my velocity vector is going to be 11, 1. So any questions on that one? So now my acceleration vector, again, when t is equal to 2, I have to find the second derivative. So I have to find the second derivative for the horizontal component and plug in a 2. And then I have to find the second derivative of the vertical component and plug in a 2. So you guys go ahead and find your acceleration vector for me. So hopefully we came up with 2036 as the acceleration vector. So any questions on finding the velocity or acceleration vectors when you're given position? So like I said, some of these questions will be calculators, some will be no calculator. So let's take a look at example 2. So again, we have a particle in the plane, they're giving us position. Find the magnitude of the velocity vector when t is equal to 1. So remember, the magnitude is the same as the speed formula. And that's going to be the square root of your dx dt squared plus your dy dt squared. So your magnitude or the speed formula, anytime they ask you about magnitude or speed, this is the formula, the same formula you're going to be using. So again, we want to also find this at t is equal to 1. So first thing I have to do is I have to find my dx dt. So then the derivative of t squared is going to be 2t. Derivative of 3t is just 3. And again, I want to evaluate this at t is equal to 1. So this is going to give me 5. So in my formula, I'm going to plug in the square root of 5 squared plus something. So next I'll find my dy dt. So dy dt again is going to be 3t squared minus 6t. And again, I'm going to evaluate this when t is equal to 1. So 3 minus 6 is going to give me a negative 3. And then I'll have negative 3 to the second power. So then 5 squared is 25. Negative 3 squared is 9. So the speed or the magnitude of this velocity is going to be the square root of 34. Okay. So any questions how you found the magnitude of the velocity vector? All right. So this one has a little twist and turn to it. So we got a particle that's moving in a plane. They're giving me x of t and y of t. And again, they're giving me from 0 to 2 pi. The path of the particle is intersecting the x-axis twice. Write an expression that represents the distance. So now we're talking about the distance traveled by the particle between the two x-intercepts. They do not want you to evaluate. So first of all, since they were talking about distance, the formula is going to be your integral from your bounds from a to b of the square root of dx dt squared plus dy dt squared. Well, finding dx dt shouldn't be too difficult. Finding dy dt shouldn't be too difficult. It's the bounds that you have to be careful of in this particular problem. So let's think about what's happening with the path. They're telling me that the path of this particle intersects the x-axis twice. So I have some particle, it's traveling, and it's going to intersect my x-axis twice. And again, it wants me to calculate the distance traveled by the particle between the two x-intercepts. So that's the distance that I need to calculate. So my bounds are going to be the two x-intercepts. So I can call that A, call that B. So those are my bounds. So my bounds are the two x-intercepts. So any questions on that? So now the question is, this is not a calculator question, so I have to find the x-intercepts. This goes back. I don't care what kind of function. How do you always find x-intercepts? You set what? We set y equal to 0. So to find any x-intercept, we're going to set y equal to 0. So I've got my y of t equation, my 1 minus 2 sine t. So I'm going to have 0 is equal to 1 minus 2 sine t. So subtract 1, divide by negative 2. So I want to find where is sine t equal to a half. So what are my t values then going to be? T is going to be equal to what? Pi over 6 and 5 pi over 6. So those are your bounds. So any questions on how I found the bounds? So now I know the bounds, the distance will be equal to, again, from pi over 6 to 5 pi over 6. Remember, you're not evaluating this, they just want you to set up this particular integral. So dx dt, again, what's the derivative of square root of 3? The derivative of square root of 3 is just going to be what? 0. What's the derivative of negative 4 cosine t? Negative 4 cosine t's derivative will be what? 4 sine t. So it's going to be 4 sine t, and again, that quantity is being squared. Plus. Now I have to find my dy dt. So I know the derivative of 1 is 0. What's the derivative of negative 2 sine t? Negative 2 cosine t squared dt. Okay. So any questions on, again, they don't want you to solve it, they just want you to set up your integral. So any questions if they're not giving you the bounds, how we have to calculate those on that one? All right, let's take a look at another example. Again, still no calculator. So now notice they're not giving you position anymore. They're giving me my function y is equal to the natural log of x, and they're giving me just the derivative for x prime. And at time t is equal to 0, the particle is at the point 1, 0. It's been a while. What is this 1, 0? This is your what? Initial condition, initial condition. So find the position of the particle. So what do you think I'm going to have to do with x prime to go back to the position? I'm going to have to do what? I'm going to have to integrate. So I want to find my position, so I want to find x of 1, because I want to find the position at time t is equal to 1. So x of 1 is going to be equal to, remember, I have to consider the initial condition. The initial condition is that time t is equal to 0. So that's going to be my x of 0. Plus, remember, wherever the initial condition is starting, that's going to be your lower bound. So they're giving me my initial condition at time t is equal to 0. So my lower bound is going to be a 0. I want to find the position at time t is equal to 1, so my upper bound is a 1. And again, I'm going to have to integrate x prime of t, which is t plus 1 dt. Well, what is the position of the particle? What is the horizontal position of the particle at time t is equal to 0? What is the x-coordinate of this point? The x value of this coordinate is what? 1. So my x of 0 is 1. Plus, when I integrate t, that's going to be a t squared over 2. Plus, my integral of 1 is going to be a t. And again, I need to evaluate t squared over 2 plus t from my bound 0 to 1. So I have 1 plus, plug in my upper bound of 1, which is 1/2, plus 1, minus 0. So what is 1 plus 1/2 plus 1? 5/2. Great. Now they want me to find the position. I have to have a position for my horizontal and my vertical. I know my horizontal component is 5/2. How the heck am I going to find the y-coordinate? Any thoughts? What can I plug the plug 5/2 into to find the y-coordinate? They're giving me my y equals natural log of x function. So y equals the natural log of x. So y is going to be equal to the natural log of 5/2. So the y-coordinate is going to be natural log of 5/2. So any questions on that one? It's been a while since we've done those initial condition problems. So let's take a look at another example. The position of the particle, and again, notice they're giving, always pay attention to what they're giving you. They're giving you position. For what value or values of t is the particle at rest? So to be at rest, your x prime of t and y prime of t have to be equal to 0 at the same time. So when you're given parametrics and you're given vectors, to find out when you are at rest, you have to take x prime of t, set it equal to 0. You have to take y prime of t, set it equal to 0. And it will be at rest at the t values that are the same for both. So go ahead and find your x prime of t and y prime of t and set them both equal to 0 for me. Check your answers up here. So we should have come up with when t is equal to 1. Okay? So any questions when given parametric equations, how you can find when the particle is at rest? All right, so this first part is a calculator, a no calculator. The second part is a calculator. So again, they're giving me position. They're giving me my x of t and y of t over my time interval from negative pi over 2 to pi over 2. Find the equation of your tangent line at the point where t is equal to 4. Tangent lines. What two things do you always have to know with tangent lines? Point and slope. How do you find the point? How do you find the point? You're going to do what with that pi over 4? Plug it in. Plug it in. So x of pi over 4 is going to be equal to 2 minus 3 times the cosine of pi over 4. What is the cosine of pi over 4? Square root 2 over 2. So 2 minus 3 times square root 2 over 2. So now I have to find the y-coordinate. So plug pi over 4 into the y equation. So 3 plus 2 times the sine of pi over 4. Sine of pi over 4 is also going to be what? Square root 2 over 2. So 3 plus 2 times square root 2 over 2 is going to give me 3 plus square root 2. Yes, they're not pretty x and y coordinates. Where's the slope going to come from? dy dx. So I have to find my dy dx. Remember, this will give me my slope. And remember, with parametrics, I have to do my dy dt divided by my dx dt. And again, I'm going to evaluate at t is equal to pi over 4. So go ahead and calculate that slope for me. Again, the y-coordinate is this. Now, be careful, guys, when this is following your subtraction sign, make sure you put parentheses around these components for the x and the y. So y minus the quantity of 3 plus square root 2 is equal to 2/3 times x minus, open up a set of parentheses and plug in the x coordinate we found, 2 minus 3 square root 2 over 2. So there's the equation of your tangent line. Okay. So any questions on the tangent line problem for the parametric equations? All right, so the next part's going to be a calculator question. The curve C intersects the y-axis twice. Approximate, because again it's going to be calculator, the length of the curve between the two y-intercepts. So we did one a few minutes ago involving x-intercepts. Let's take a look at the y-intercept. So again, we're talking about the length of the curve. So the length, we're going to use that arc length formula going from A to B. And that's the square root of your dx dt squared plus your dy dt squared. So we want to calculate, so this curve is intersecting your y-axis twice. Again, it's asking us to calculate the length of the curve between the two y-intercepts. So that's the length of the curve I want to find. So just like I did a few minutes ago, the y-intercept is going to be my bounds. So I don't care what kind of function I'm asking you about y-intercepts. How do you calculate the y-intercept of any function? What do? You set x equal to 0. So I'll take my x equals equation and set it equal to 0. So 2 minus 3 cosine of t is equal to 0. And this is why it's a calculator question. So what mode, refresh my memory again, am I going to be in on my calculator? Radian. So what I'm going to do is just type in under my y equals, type in 2 minus 3 cosine of t. Again, I'm just going to use x. Now, in the directions, remember, we're only looking for t values from negative pi over 2 to pi over 2. So when you are, because remember, when you're graphing these trig functions, you get a whole bunch of curvy lines. So make life easy on yourself. Change your settings on your window. Remember, instead of using t, I'm using x. So change your x min to negative pi over 2 and your x max to pi over 2. That way you're going to see, again, we're looking to see when this is going to be equal to 0, so we're looking at the x-intercepts. So this is going to give me the values, the t values, or those x values only between negative pi over 2 and pi over 2. So then to solve this equation, I need to find these x-intercepts, which I can go under my second trace and go to the 0 function. So move cursor to the left to find one of them. Go to the right. So t is equal to negative 0.841. So any questions on how I found negative 0.841 there? So now I need to find the other x-intercept. So again, I'll go under second trace, 0 again. I think it's going to be the same but the positive value, but let's double check it. So positive 0.841. So any questions on how I found the bounds here? So now, to find this arc length, I know it's going to go from negative 0.841 to positive 0.841. Again, it's going to be the square root. Again, dx dt is going to be 2 minus 3 cosine t. So the derivative of negative 3 cosine t, that's going to be a 3 sine t squared. Plus your dy dt, the derivative of 2 sine t is going to be a 2 cosine t. So any questions on how I have the integral set up there? So now, the calculator, remember, what you want to do is type what's underneath the radical so that you don't have to worry about the parenthesis usage. Type everything underneath that radical under your y1 on your calculator. So type in parentheses 3 sine of x squared plus parentheses 2 cosine of x. Square it. So now, when you go back to your home screen, again, you can go under your alpha window, go to your option 4, which will give you your integral. So my lower bound is negative 0.841. The upper bound is positive 0.841. Now all you have to do is type in that square root of what's under y1. So go to your alpha trace to get y1 dx. So 3.756. About 3.756. Okay. So any questions on using your calculator? It's been a while since we've used our calculator for integrals, so questions on that? All right, almost done. This is kind of a review what you had to do last night for homework. Remember, with parametric equations, you have a horizontal tangent line when your dx dt, or excuse me, dy dt is equal to 0, and dx dt is not equal to 0. You have a vertical tangent line when your dx dt is equal to 0, or you set the denominator equal to 0, and dy dt is not equal to 0. Okay. So you guys go ahead and try part A for me. You can use your calculator. So for what value or values, again, you're only looking from 0 to 2, does the curve have a horizontal tangent line? So you guys go ahead and try part A for me. So did we all come up with, ladies and gentlemen, about 1.253? Any questions where I got 1.253? Okay, so now go ahead and do part D, because we have to confirm that, remember, dx dt is not equal to 0 at this particular point. So now go ahead and do part B for me. Find out for me, when does the curve have a vertical tangent? So again, remember, for the vertical tangent, you're going to set that dx dt equal to 0. Yeah, we're using a calculator. And guys, be careful with the calculator questions. When you're setting your window from, like, for example, we set our window from 0 to 2, you may want to make that viewing screen a little bit outside those bounds, like maybe like negative 0.5 to 2.5, because on the calculator screen it may appear that there may be one intersection point really close to 0 or 2 that you may miss. Because you should have 3 places. And one of those places is 0. So that's why I expanded my window out a little bit further so I could see that it is clearly going through the origin. You could also confirm it from your table. When x is 0, y is equal to 0. So just be careful when you're adjusting those windows using your calculator. So any questions on A or B? Part C, finding the acceleration particle at t is equal to 2. So now remember, this is where we want to find your second derivative at 2 for both your horizontal and vertical components. So remember, guys, on your calculators, you can do derivatives. So again, we can do that second derivative. So if I plug in, so for example, to find x double prime of 2, again, I have my dx dt, which is sine of t to the third. So I'm going to type in my first derivative under y1. Then what I can do is go back to my home screen. I can go to alpha window, choose option 3, and derivative, and take the derivative of the function I loaded under y1. So then go to alpha, trace, and select y1. And again, I want to evaluate this at x is equal to 2. So I end up with negative 1.746 as the acceleration vector's horizontal component. And then go back to your y equals and type in the dy dt, which is the cosine. Go back to your home screen. And again, I can just save time and go back and do second recall. It will automatically, if I hit second enter, it will automatically bring back what I previously typed in, so I don't have to you can retype it in if you want. And it will automatically plug in that new y sub 1 function for you. So we're at 3.027. There's all kinds of things you can do. All right, are we good on the acceleration vector? You guys go ahead and do part D for me. Write the equation of your tangent line. Again, we found tangent line problems, point and derivatives. So ladies and gentlemen, hopefully you all came up with your slope to be negative 0.661. Again, ladies and gentlemen, be careful, because at the time t is equal to 2, if you reference the original problem, before you go through and have to do integration and figure out what the point is, see if they gave it to you. So they actually gave you the point that you needed to write the equation of the tangent line at t is equal to 2. So all you really had to worry about doing was finding your slope. All right, so any questions on part D? So next is speed. So to find the speed, remember speed is equal to the square root of your dx dt squared plus your dy dt squared. Again, remember, they're giving you dx dt and they're giving you dy dt. So go ahead and calculate what the speed of this vector is going to be at t is equal to 2. So we all come up with about 1.186. So any questions on finding the speed? So now, last part is find your position of the particle at time t is equal to 1. So notice they're giving us your dx dt and your dy dt. So position, you have to find the x and the y coordinate here. So again, to find your x of 1. So x of 1, remember, the initial condition they're giving you as at time t is equal to 2. So what is the horizontal position at time t is equal to 2? The horizontal position is what? 1. So then my x of 2 is 1. Plus. Now remember, my initial condition is starting at time t is equal to 2. So the lower bound is going to be your 2. And we want to know what the position is at t is equal to 1, so the upper bound is going to be 1. Now, you don't have to, since this is a calculator question, we can just type it in right as it is. You don't have to worry about negating it and changing your bounds and everything. So then again, what I'm going to have to do is I have to integrate my dx dt, which is the sine of t to the third dt. So then, to find my vertical component, to find y of 1, again, what is the position of the object at t is equal to 2? The vertical component is going to be what? 4. So then y of 2 is equal to 4. So I have to take 4 and add it again to my bounds from 2 to 1. And I have to integrate dy dt, which is given to me as cosine of t squared dt. So any questions on how I set up those intervals? So you guys go ahead and finish it for me. Calculate the horizontal and vertical components for me. Go ahead and do the next 3. These are actual multiple choice questions from prior AP exams. So go ahead and try those 3. I'll give you guys a few minutes to work on those, and then we'll go over them. Here, so for the first multiple choice question, again, they gave you your dx dt. So if I integrate dx dt, and again, my initial condition is at time t is equal to 1. At time t is equal to 0. So my x of 0 is actually 1, so that's the initial condition. And then again, I have to take 1 and add it to the antiderivative of t plus 1, which is a t squared over 2 plus t. So I end up with that horizontal component to be 5/2. Now they're giving me my original equation, y equals the natural log of x. So to find the y coordinate, I can just simply plug 5/2 in for x. So the answer should be C. So any questions on the first one? The second one, again, equation of any tangent line, you have to know your point, you have to know the slope. Again, they want to know the equation of your tangent line at t is equal to 1, so I can just plug 1 in for t to come up with my x coordinate, which is where I get the 2. Plug 1 into my y equation to come up with my y coordinate of 3. And then I have to find my derivative to calculate the slope. So I should end up with a slope of 2. Now remember, on multiple choice, free response questions, okay to leave your answer choices in point slope form, but if you look at all your answer choices on this one, you do have to change it into slope intercept form, which sometimes they'll do on multiple choice. So any questions on how I got C for that one? And then the last one, again, a big red flag here is looking at what they give you, what they want you to find, and nowhere do they actually give you an equation where dy dt and dx dt is actually in it. So looking at this equation, x times y equals 10, to get a dx dt and get a dy dt, you're going to have to take the derivative. So using your product rule, again in your implicit differentiation, the derivative of x with respect to t is my dx dt times y, that's my fig, plus figgy. X times the derivative of y with respect to t is your dy dt. Now they told you that x is equal to 2. Well, if x is equal to 2, you can find out that y is equal to 5. and then plug in the values that you know and solve for dx dt. So we end up with negative 6/5 is the answer. All right. So any questions on vectors? All right.